Hello everyone, welcome to the world of Lean Six Sigma. I am Mohit Sharma, your mentor and coach on Lean Six Sigma issues and problems. Today we are going to solve a problem which is in the software industry with the help of Lean Six Sigma. Software code defect reduction is the name of the project that we are going to do. And what is defect density and how it is reduced, this is what we are going to learn throughout the video. In this video, we are going to use certain Lean Six Sigma tools like project charter, fishbone diagram, Pareto chart, and root cause analysis and solution identification. So let's begin. ABC Technology is an IT-based organization where they develop softwares that are used along with their electronic products. Team is facing a challenge that their software code have defects. This situation is causing them delays in delivering the software, and it is also causing revenue delays and eventually loss of customers. The development team manager decided to reduce these software defects in codes. They formed a Six Sigma team led by a black belt. Team decided to reduce the defect density as a metric. Defect density measures the number of defects per unit of code, typically per 1000 lines of code, which is KLOC. The formula of defect density is equal to number of defects divided by KLOC, thousands of lines of code. The first thing the team did was to create a project charter. I have already explained to you the business case of the problem. They collected data for last 6 months and they found out that the defect density is 1%. The team took a goal to reduce this defect density from 1% to 0.5% by June 2017. The in-scope is DA software team and the out-of-scope is all other departments or any other software development team. They started their project in March and they wanted to finish it in June. So the team was on a tight schedule. The sponsor of this project was IT director, the champion was the senior manager, IT department, and there is a mentor, there are process owners and the team members. Friends, you can buy my authored books on Amazon. My first book is 8 Steps to Problem Solving, which talks about Six Sigma concepts. And my second book is Continuous Improvement the Lean Way, which talks about the lean concepts. So the team did a brainstorming session and identified some of the root causes to this problem. So under people, they had poor design, human error, and insufficient knowledge or skill. Under process, they had inadequate requirements, lack of code reviews. There were some root causes listed under others, which is poor communication and collaboration, time pressure and deadline. Under procedure, they had inadequate testing, changes in the code base, which are some regression issues, and insufficient documentation. And then under place, they had environmental factors, unclear testing criteria. So I will use Minitab to create a fishbone diagram. So first I will go to Stat, Quality Tools, and Cause and Effect Diagram. So this fishbone diagram is also known as Cause and Effect Diagram. The effect is the problem, which is the defect rate. In causes, I will enter people and change the label to people. In the second one, I will enter process and change this to process. And third, under causes, I will enter procedures. Fourth is place. And the last one, I will select other and I will say others here. And I will also check do not display the empty branches so that this empty branch will not be displayed, and click OK. Now you can see the fishbone diagram. So under people, poor design, human error, insufficient knowledge. Under procedure, it is inadequate testing, changing in the code base, and insufficient documentation. All of this is listed like that. And the head of the fish is the defect rate. Friends, you can buy my authored books on Amazon. My first book is 8 Steps to Problem Solving, which talks about Six Sigma concepts. And my second book is Continuous Improvement the Lean Way, which talks about the lean concepts. The next thing the team did was to collect some data on these defect types. Like poor design had 78 defects, human error there were 25, insufficient knowledge or skill 15, inadequate requirements 63. So all of these defect types, they collected data against them. The next thing the team did was to prioritize these defects based on the data. So they created a Pareto chart. They will go to Stat, Quality Tools and Pareto chart. Under defects or attribute data, you will select the defect type, and under frequencies, you will select the count of defects and you will click OK. So this is the kind of Pareto chart that you will get. You can see 80% contribution is because of the first 5 error types, which is inadequate testing, poor design, inadequate requirements, insufficient documentation, and human error. So once this has been identified, then the team created a root cause analysis and solution identification plan. So let's go to the PPT and understand that. So the problem was inadequate testing, and the root cause is the lack of comprehensive testing, unit test, integration test, or system test, or failure to test the edge cases can allow defects to go unnoticed. That was the root cause why this inadequate testing was causing a problem. And the solution was that the automated tests, manual tests, and the continuous testing, the team decided to create an automated test suite to test the software early. This is one of the solutions to the problem, which is inadequate testing, because of which there were defects in the software code. The second was the poor design, and the root cause of the poor design is the architecture or design decisions are flawed and they create challenges during development, integrations, and maintenance. So what the team decided that they will do for this is to perform the architecture reviews, use metrics and logos, leverage system metrics, performance monitoring tools, and logos to identify the bottlenecks, slowdowns, or errors that may indicate the poor architectural design, and conduct code audits. That was also one of the solutions to the poor design. So which is also tying back to our first solution of automating the test suite. The third one is the inadequate requirement. So incorrect functionality, missing features, or functionality that doesn't align with the user needs is basically the inadequate requirement. The root cause of this was the customer requirements were poorly defined or misunderstood by the developers. That leads to unclear, incomplete, or ambiguous software development requirements for them. So the solution that they identified for inadequate requirement was that they will do effective stakeholder engagement. Clear and detailed documentation is also one of the important solutions. And the third one was iterative and incremental development, means they want to use agile methodology. You can watch some videos on agile methodology on my channel. And the last but not the least, they were conducting prototyping and mockups for inadequate requirement. What is prototyping and mockups? You have to create the prototypes, the wireframes, or mockups of the software to visualize the system early on. You can build the low fidelity prototypes or wireframes to showcase the basic functionality and the user interface of the software. Allow stakeholders to interact with these prototypes and give feedback before full-scale development begins. Tools like Figma or Adobe XD can be used to design these prototypes. So basically, if you follow agile methodology, you will be able to do all of this. Moving on to the next two problem areas, one of them was insufficient documentation description, and the impact is the programmer will misunderstood the features, there will be poor maintenance and higher chances of defects when working with the legacy code. So the root cause was lack of poor documentation led to misunderstanding in code logic, functionality, or system behavior, especially when other team members need to modify or extend the code. The solution to this is establish the documentation standards and guidelines, document the high-level design and the architecture. Inline code comments or doc strings is one of the solutions. What is inline code comment and doc string? Person should include meaningful inline comments and doc strings for functions, classes, and complex logic to clarify the intent behind the code. That is most important. And how you can do it? Write doc strings at the beginning of the classes, method, and functions to explain their purpose, parameters, and return values. You can use standardized formats such as Google style or restructured text. For complex or non-obvious logic, add inline comments explaining why the code is written in certain way, especially if it addresses a specific problem or performance optimization. The next one was the human error. The impact of the human error is the syntax errors, logic errors, missed edge cases, and incorrect calculations. So mistakes made by developers during coding introduced defects. These errors involved simple typos, incorrect algorithms, or misunderstanding of the complex requirements. And the solution is implement automated testing. So this is again one of the solutions which is tying back to our solution number 1. So use automated unit tests, integration tests, and end-to-end tests to catch these errors early in the development process. And how you can do that? You can write the unit tests for individual functions or methods to verify that each part of the code works as expected, and develop integration tests to ensure that different parts of the system work together properly. Use end-to-end tests to validate the entire system's behavior in real-world scenarios. You can also incorporate the test-driven development where developers write tests before writing the actual code. So friends, with the help of these 5 major implementations, team was able to reduce the defect density from 1% to 0.5%, and hence the overall project was a success. So friends, if you really like this video, please give it a thumbs up and share this video with your friends. I will see you in my next upcoming video. Till then, take care. Bye bye.